Hey everybody, today we are going to be finding the nth integral of x to the a, right? We already found the nth derivative, and if you haven't watched my video on that, I encourage you to do that. I'll probably link it somewhere right now, I don't know. But this is a continuation to that, so I expect you to understand how to find the nth derivative, the process we're going to use, and what the pi function is, because I'm gonna use it without really explaining it today. So if you haven't watched that video, I encourage you to do so, because the process is very similar. All right, so original function is x to the a, so we can just write that x to the a. All right, our first integral, which I'm denoting using i's, because I mean I could write like the integral of f of x dx dx dx. That's just kind of repetitive, and when you have the nth integral, it's kind of weird. So I'm using this notation. I think it's like Newton's notation or someone else's. I don't know. But yeah, so our first integral is going to be x to the a plus 1 divided by a plus 1. That's just basic integration rules. I'm going to forget about the plus c because that's not really relevant. I mean, you could add it, but we'll do that at the end because it'll be just one big constant basically. So the second integral is going to be x to the a plus 2, because we're adding 1 to a plus 1, divided by not just a plus 1, but a plus 1 times a plus 2, because a plus 1 is just a constant that we can factor out of the integration. So then we have this new constant that's going to be a plus 1 times a plus 2. And I kind of cluttered it together a little bit here, but bear with me. I wanted to leave some room down here for computation. So our third integral is going to be x to the a plus 3. We're dividing this by a plus 1 times a plus 2 times a plus 3. Alright, that's a lot. But yeah, you can actually already see the pattern here. So we're going to have this, I'll do this big thing there. So x to the a plus 4. So then we have a plus 1 times a plus 2 times a plus 3 times a plus 4. Alright. So that is our fourth integral of our function. So now we can notice the pattern. It's going to use one of the pi functions, but we need to know exactly how, because it's not the same. It's similar to our derivative, but it's not really the same. So we can notice that we're going to have, so we're going to start at a plus 1, we're going to go a plus 2, we're going to go all the way to a plus n. This is actually a lot easier than the nth derivative, because this number matches with that number. And so this also up here becomes x to the a plus n. That's a very bad a. Oh man. X to the a plus n. Okay, so this is actually a very neat looking expression. Now we just need something for that. Okay. It's actually not hard, because we can do the same process that we did last time. It's actually very easy. So it's going to be in the denominator, but we're going to have the pi function from, well, we start at a plus 1, so I'll do k equals a plus 1 all the way to a plus n. Alright, so let me just make that k a little better, and that's going to be a k. Right, and then this becomes x to the a plus n. That's it. That's really it. I mean, we could actually extend this further, and remember we have the a's there. We could say this is the pi function of a plus k from k equals 1 to n. So we're going to take that, x to the a plus n, and so yeah. And then, of course, we can add our plus c, so plus c, and that is our expression. It's a very bad box right there, but that's it. I mean, it doesn't look that good because it's got the pi function on the bottom, and it's just kind of clunky, but it's actually a lot neater, in my opinion, than our nth derivative. And it's very easy to see. Once you understand the pi function, it's actually very easy to see how it's just going to be very similar. So yeah, that's the nth integral. I'll be making more videos in the future, so thanks for watching, and I'll see you later. Bye guys.